All right, hello everyone. Um, this is a very different and also sort of the same kind of lecture I used to give back during the COVID times. Um, Hello everyone. So yeah, I had, you know, a bunch of car trouble, and so I just could not make it in today. So today we're going to do a lecture on we're going to do this lecture here. So, one thing I want to say is that I did actually finally get the GitHub up and running. So here is the GitHub. I'll post a link to it. So that's the link to the GitHub. I'll post a link outside of the lecture at the end of the lecture. But yeah, you can actually access the code from the first lecture and today. I think I have a little intro text that you don't have to read. It was just, what does it say? It says, these should be all the lecture notes. Yep, that's all it says. Okay, so that's basically where all the code is going to be, and that's what I'm going to upload the code from today as well. So, all right. I guess I should show you a little bit. So let's go and look. So for instance here, if you wanted to look at some of the code, you could like click on that, and here's the code from, I guess, the 1 p.m. lecture from the previous conditional lecture. Okay, yep, whole bunch of stuff. And just remember that sometimes there's an if false at the top. I don't always remember to remove it. Okay, so let's begin today. Let's talk more about conditionals. So remember, conditionals are basically, in our case, they're if statements, right? So the syntax for an if statement is you're going to have if and then a condition and a colon, right? So that's the syntax. It is if, a condition, and then a colon. And the colon tells the if statement that it's over. The condition has to evaluate either true or false. Okay? So, and then you can type code. So remember to all code inside of the if must be tabbed by 1, right? And this is still inside the if. This is also inside, and then finally this is not inside of the if statement. Okay, so we also talked about the last time we talked about the Boolean operators. We talked about and, or, and not, and we had a long discussion about which one has the highest precedence. The good news is that the important thing to learn is that not has the highest precedence. And then, as it turns out, and is in the middle and or is at the lowest precedence. So that's what we learned last lecture at 4 p.m. And so also remember that in general, when precedence happens, you have 3 stages. You have algebra, and then you have comparison operators. And comparison operators go like this. So comparison operators basically work like, what should I say? They work like equals, not equals, less than, greater than, less than or equal to, and greater than or equal to. So those are the comparison operators. And then the last one is Boolean operators. Okay, or I guess I could call it Boolean or logical operators. So I kind of use both terms now. All right. So now today I want to talk about, there's 2 things I really want to discuss today. First, I want to talk about nesting if statements. Or maybe I'll leave that to second. The first thing I actually want to discuss is probably Elif and else. Okay? So we want to discuss Elif and else. So remember, if you have an if statement, so if you have x is equal to, say, int of input of, tell me int, and then you have if x is bigger than 0, we can do something like print if x is positive, right? And so, you know, that's a good old-fashioned if statement. Let's run this to tell me an int. I'll say 17. X is positive. right? But if I enter -3, the problem is that nothing happens, right? So the problem with this is if I enter nothing, or I'm sorry, if I enter, say, -3, nothing happens. And that's not exactly a problem, that's not wrong, it's just that the, sometimes what we want to have is that we want code that executes, we want code that executes when the if statement is false, right? So if the if statement is false, how do we get that to happen? So basically what we can do is we can have if x is bigger than 0, right, print x is positive. And then we can actually use the keyword called else. X is either 0 or negative, right? So that's basically the syntax, right? So the syntax for it is just else and then a colon. Okay? And you put it after the if statement. So it doesn't go inside of the if statement. So it doesn't go like this, right? It's not tabbed in by 1. It's at the same level as the if statement that it applies to. So for instance here, this if statement, if there's an else following it, that means that if the if statement is false, it'll fall into this little bit of code here. So now let's run this and see what happens. So tell me init, we'll say 17 again. And so of course it says x is positive twice. Let me kind of comment this block out so that it doesn't say that. And then let's enter -5, right? So here what it does is it says, is x negative, or is x positive? And the answer is no. So then it jumps down to this else statement and executes this little bit of code here, right? So that's, you know, one way to do things. So, yeah, so basically, you know, if we have something like if you enter x and we say, okay, let's do x is equal to int of input, you know, enter numerator, and, you know, y is equal to enter denominator of like a fraction, then basically before we do any division, we would say, you know, if we say if, say y is equal to 0, or let's say if y is not equal to 0, we can print the fraction is equal to, right, x divided by y, right? And we can just do it as a floating point. But if y is equal to 0, then we want to print out the denominator is 0. Cannot divide, right? So that's one little bit of code where it's actually kind of useful. So let's do something here. So tell me an int 123 or whatever. Tell me a numerator. The numerator is going to be 40. The denominator is going to be 5. And so we should get, what, 8.0 because it's doing floating point arithmetic. Yep. And so if we do it again, except, you know, tell me int, enter a numerator, let's say 6. Enter a denominator, we'll enter 0. And then here it'll tell us that the denominator is 0 and can't divide, right? If we tried to do this outside of the if statement, the problem is that if we say, okay, numerator is 8, denominator is 0, and we don't have this code sitting inside of an if statement, then the problem is that we're going to get a 0 division error, right? So that's a little bit of a problem. We don't want 0 division errors. So let's get rid of that little code. Okay. Fair enough. All right, so let's talk about something like, let's talk about Elif, right? So we've done if. So okay, maybe we'll do another one. So we can do it with strings as well. So maybe a password, right, is equal to input, say enter the password, right? And then what we're going to do is we'll say test the password. So we'll have if password equals correct password, right? Then we'll print, you know, you have logged in. And maybe we'll set logged in to true, right? And so maybe correct password is secret password 1, right? So, but, you know, sometimes you want to display a user message to the user. We want to say, you know, you haven't logged in, so incorrect password. You have not logged in. Right, so that's a way to ensure that, and I guess we could even set logged in to false if you something like that. Now, of course, I'm never actually going to use this logged in variable, but maybe, if logged in, right? Maybe I am going to use it. Then what we could do is we could say print, choose what to do, or like input, say pick a number between 1 and 10, right? Or something. Right, and this will only happen if you're logged in. If you're not logged in, it's not going to do this. So for instance here, let's say, tell me an int, 5, tell me numerator, 2, 2. Okay, enter the password. So I'm going to enter I'll say, whatever, right? So I'll enter something incorrect, right? And when I do that, what's going to happen is that you notice that once we don't enter the password and it's not equal here, what ends up happening is that it says logged into false, and so because logged in is equal to false, this if statement doesn't get executed, right? Yeah, so this will become a video after the stream, right? So thankfully I don't actually have to do anything about that, it just does it automatically. Yep. So, okay. So that's all stuff, right? So we've learned a little bit about else, right? And so now I want to talk about elif. Okay, so I'm going to put all this into a giant if false, right? And then we'll start over. So down here I want to talk about, so what is elif? And the answer is, in a lot of programming languages, you actually have something called else if. And so what it really means is, if the first if statement isn't true, try this one instead, right? And so the thing is that they are basically linked together. The way to think about it is that each else if is linked to the if statement above it, and it only executes, or it only checks if it's true whenever what should we say, if the original if statement is false, is false. And so let me show you a little bit of an example of elif. So let me say that we say x equals int input, tell me, give me number. And so if we say, let's say if x is less than 0, let's say between 1 and 10, right? So if x is less than or equal to 0, we want to print okay, so how about we do this? We say 1 is less than or equal to x is less than or equal to 10. We print, you have chosen correctly, right? So this means you've chosen the right set of numbers. But now if we say elif, x is bigger than 10, right? We can print out, you are too high, right? And then again, we can say else, right? And so here we can actually just say else, because if someone picks a number that's not bigger than 10 and not between 1 and 10 inclusively, then it has to be less than 10, so we can print out, you have to pick a number, or I guess we could say too low, right? So that's what we can do. So we can chain together an if statement with an elif with an else. And so let's go through all the cases here. So let's pick a number between 1 and 10. Let's pick 5, right? Okay, you have chosen correctly. So what that means is that we've picked a number between 1 and 10, and our code is happy. It goes into the first if statement, right? And so now let's pick a number, let's say -3. Well, actually, let's pick a 12, right? The reason why I want to pick 12 next is because what happens? What happens is that it's going to not be between 1 and 10, so it's not going to be in here. What it is going to do is it's going to go into this elif statement, right? So this elif statement is connected to this if statement. As soon as this if statement doesn't execute, this will execute, and so it'll say you're too high, right? And then here, let's pick, say, -2, right? And then it says too low, right? So that's how we get it to execute in all the different cases. And there is a slight difference, right? So you might ask yourself, well, why don't we just do something like if? So in this case, actually, we can sort of do that. But in a lot of cases, it's not as easy. So let me show you another example. So let's say that we want to pick, say, number of, I don't know, what is it, like number of apples, right? And we'll say that's int of input of, how many apples, right? And so if we say, let me show you an example where we do something that's very similar but not exactly the same. So we say, if number of apples is less than 0, we print, that doesn't make sense, right? Right? Pick a positive number. Or, I guess, a non-negative number, at least. And then we say, okay, Elif, number of apples, right, is less than, let's say, 12, right? Then we can say print, you have less than a dozen, right? And then maybe we'll add another Elif statement. So we say Elif, number of apples is equal to 12, right? Then we print, you have exactly a dozen, right? And then finally we say Elif, number of apples is bigger than 12. Then we print, you have, I guess we could technically use an else here, right? So we don't need another Elif. You have more than a dozen. Right? So we can have this set of Elif statements. Now, let me show you how this works, right? So what is this going to do? First, let's give a number. Okay, how many apples? Let's pick 6 apples. So with 6 apples, it says you have less than a dozen, right? And let's say, give a number, 0. Okay, how many apples? 12, right? You have exactly a dozen. And then let's give another number, 5. How many apples? Let's say that you have, I don't know, 15, right? So if you have 15, then you have more than a dozen. Okay, so we've gone and actually we didn't go into this condition, so we'd have to enter like negative something to go into that condition. So, but you see that only one of them executes, right? So the important thing to learn about if, elif, and else. So if, elif, and else only will have one of them execute in a given run. Okay, so what that means is that, basically if this if statement goes off, it's not going to check anything after it. If this if statement goes off, it's not, or this elif statement goes off, it's not going to check anything after it. Similarly, here, if the number of apples is equal to 12, it's not going to go to the else. Now let's write an equivalent bit of code, right? Let's copy paste the code. Only what we're going to do is delete the elif statements, right? So what happens if we delete the elif statements, right? And so the thing about this is that if you look at this code, what it's going to do, let's enter a number. So if we enter, let's say 12, then the good news is that, you see, it's not going to execute this because 12 is not less than 0, 12 is not less than 12. So this actually does work. But there's actually a condition where this is not going to match the output. And here's one of the examples of the condition. So let's say that let's say that we have 5 apples. That's one condition where it's not going to match. So we say here, and then we have, if you look at this if statement, it's going to say you have less than a dozen, right? But then it's also going to say you have more than a dozen. But why is it going to say that, right? Why is it going to say that? The reason is because basically once you create an if statement, all the elifs and the elses under it are attached to it. But if you create another if statement, this if statement here is separate, right? And also this if statement here is separate. So this if statement runs, and then it doesn't matter if this one was true. It'll run this one anyway. So there's actually a way to make both of these messages pop up. Actually, this one, this message, and this message. You can make them, all 3 of these messages pop up if you pick, say, -5 apples. Because if you pick -5 apples, what's going to happen is, it's going to say, is the number of apples less than 0? Yes. So it's going to go into here and say, that doesn't make sense, pick a non-negative number. But then because this is a separate if statement, it's also going to go into here. And it's also going to say that -5 is less than 12. So it's going to give us, what should I say? It's going to give us the number of apples is less than 12. So it's going to give us, -5 is less than 12, so it's going to print this out. it's not going to print this one out, but then this else statement is still attached to this if statement. So it is going to print this out. So that's why we get all three of those outputs in instead of just one, right? So the elif statements, this business here, this is what we kind of want it to be. This is what you might accidentally do if you just use if statements and you don't chain them together, because basically this if statement and this if statement and this if statement are completely independent. So there might be conditions where the number of apples is less than 0, but if it's not equal to 12, then, well, so if it's less than 0, then it's also less than 12. So if it's ever less than 0, then this will also print out, which you don't really want. And then also here, if it's just not equal to a dozen, then that's going to print out too. So you could put if statements inside each other. That's actually a different thing. So so the answer to your question is yes, you can put if statements inside each other, but that's called nesting. And I'll show you how nesting works. So right now, all I wanted to talk about was if and elif and else. I didn't want to talk about nested statements yet, just because it does increase the complexity just a little bit. But let me just do one last example with if and elif and else. So let's say, here's an example. Tell me a day of the week. Okay? So we're going to tell the thing the day of the week. And so what we're going to do is we're going to say if day of the week is equal to Monday, right? And maybe we'll even use a dot lower to make sure that it's all lowercase. Whoops. I'll get it right eventually. There we go. Okay, now it added 2 more. Cool. We'll print Garfield hates Mondays, right? And then we'll say elif day of the week dot lower is equal to Tuesday. Then what are we going to print out? I don't know. Print out Tuesdays are much like Mondays, except one more day. Elif day of the week, right? Dot lower is equal to, say, Wednesday. Then what will we print out for Wednesday? We'll print out something like when Wednesday, halfway through, right? And then elif day of the week dot lower is equal to Thursday, right? Then we'll print out Thursday, almost there, and elif day of the week dot lower, right, is equal to Friday. Then we can print out Friday, made it to the end. And right, so that's basically all the days of the week. So now what we can do is we can say else, or maybe we'll say elif day of the week equals, let's say dot lower is equal to Friday, or Saturday, I'll say. Or day of the week is equal to, dot lower is equal to Sunday. Then we'll print out something like, it's the weekend. So remember, I have to use an escape sequence. In order to get a single apostrophe inside of a string that I start with an apostrophe, you have to use a backslash. It's the weekend. And then finally, we can say else. Print, that is not a day of the week. So let's look at this code for just a second and think about what it's doing, and then let's talk about the things that we're learning from this piece of code. Like, why am I writing all of this out? So the reason why I wrote all this out is because I wanted to show you that, as it turns out, you are allowed, right? You are allowed to use as many elifs as you want. Okay? In this case, we have 1, 2, 3, 4, 5 of them. So that's how many elifs we needed. That's how many elifs we used. There's generally smarter ways to do code like this, but just with if statements, we don't actually have that, right? So with if statements, don't really get us anything smarter than this. So that's unfortunate, but whatever. You know, this is code that works. So let's actually play with this code and test it out. So first things first, let's move all of this code into that if false. That way we're only running this because we don't want to get involved with all the other code. So let's do something. Let me tell you a day of the week. So let's enter Thursday, right? Thursday, almost there, right? And let's enter Monday. Garfield hates Mondays. And let's enter, I don't know, Friday. Made it to the end. Let's test out our Saturday and Sunday code. So let's enter Sunday. It's the weekend. Nice. And then let's enter, I don't know, Blurg's Day, right? This is not a day of the week. Okay, but it should be. Cool. So the thing we learned here is that you can have as many elifs as you like. You can only have one if and only one else, right? So you can't, here's what you can't do, right? You can't have two else statements like this. And the reason for that is that Python detects the fact that there's two else statements. It's like, hey, you already have one else statement. What are you doing with this other else statement? Because remember, if an else statement executes, what this means is that all of these if statements, all of these elifs were false. And so what that means is that it's going to go and it sees that there's an else here, and then it does this print statement. And then it gets here and it says, wait a second, we've already handled that case, right? So it doesn't allow you to have two different cases where you have something like that. But you can just have multiple lines. You can have tons of lines of code inside of the else. That's okay. The only thing you can't do is you can't have two else's, right? So, yeah. Only one if, because that's how you start. And only one else. Otherwise, it doesn't make sense to Python. And so the other question I should ask is, do we need an else? Let's say that I don't care here. Do I have to put if I have an elif, do I have to put an else? And the answer is no, right? I could just delete this code. And if I ran this and said, you know, Friday, it would still work. If I said Monday, it would still work. Even if I said Blurg's Day, right? It would still work. And by work, I mean, it's going to say, is it Monday? No. Is it Tuesday? No. Is it Wednesday? No. Thursday, Friday, Saturday, or Sunday? No. And then what? Right? There's no else statement here. So because there's no else statement, it just drops through, right? It just goes to the next line of code. It's done. It doesn't have to care, right? So with an else statement, it's fine. You don't have to have an else statement. So, so really we should say the number of else's is either 0 or 1. So you don't need to have else, but you can. Okay. Actually, here's a question I never tried this because this should not work, but let's see what happens. Of course, it's always dangerous when I try something. So it doesn't like this. Why doesn't it like this? Okay, so the real problem here is that else has to be the last thing, right? So right, it has to be at the end of the if and the elifs. You can't put an elif after an else, so that also doesn't work, right? So okay, good. All right. So that's if and elif in terms of how to use it. So remember, you can have as many elifs as you want. You can only have one else. You don't need to have one. Let's do another example of if and elif, maybe. Or maybe let's do an example of nesting. So let's say, what's a good example of nesting? So, yeah, let's do this. Right or left equals input. Do you want to turn right or left, right? So we have a little choice. And so we say if right or left is equal to right, we'll do something. And elif right or left, oops, is equal to left. We'll do something else, and then else will say print you need to enter right or left. Okay, so the first thing to talk about is what the heck is pass, right? Because I just used it. So what is pass? Pass is what we call a no-op, or you can call it like a no-op like that, or sometimes it's just NOP. And what a no-op is, it's a no operation, which means that it does nothing. Okay? But the reason why we need pass in a language like Python, so then the question is, why do we need a line of code that does nothing? Right? And the reason why we need it is because sometimes, you see how I wanted to write this if statement, and I don't really know what I'm going to put in here yet. I want this code to actually work. I don't want any errors in it yet. So what I want to do is I want to leave a placeholder for future code, okay? But the thing is that if I don't want to write that code right now, if you have an if statement, you know that you have to tab everything in by 1, right? So, you know, if you have an if statement, for instance, in an if statement, all the code needs to be tabbed in by 1, but 1 level, I guess. But if we don't have this pass, you see that there's a little red underline right here. And this little red underline says indent expected. And the reason why it wants that indent is because it sees this blank line and it says there's no code on this line, so I'm going to ignore this line. I'm going to go to the next line. And I expect this line to be tabbed in. But here it says an elif. There's a lot of problems with that. So in order to get it to just say an empty line is okay, right? That's what this means. It's an empty line is okay. Counts as a line of code. Right? But pass doesn't actually do anything. Right? It's just a placeholder, really, in Python. Okay, so now let's get rid of pass. And let's add in some code. So now let's say, so we go right or left, and what's another choice? So if you go right, maybe we'll say input how many apples do you take, right? And then we'll say apples, right? Equals int of input. And then over here, maybe we'll have to, maybe if you turn left, you're going to take oranges, right? So the point here is that if you turn right, you can only take apples. And if you turn left, you can only take oranges. And so let's keep going. So if we have, let's say if apples is bigger than or equal to 12, we'll say print you have chosen a dozen or more apples, right? Else we'll print you have chosen less than a dozen. And maybe we'll say over here, let's say if the number of oranges is, say, what's a good thing? Equals 13, we can say print you have chosen a baker's dozen. Right? Because baker's dozen is 13. Else we can print you have not chosen baker's dozen. Right? So the way that these statements work is that, well, let's just watch it happen, right? So I think, yeah, I think all we're gonna do, let's just play with it for a little bit, see what happens. So here, what we're gonna do is we're gonna say, tell me a day of the week. I'm gonna say dog day, and then I'm gonna say, what do we turn, right or left? So let's turn left, and I take 13 oranges, right? Oh, nice. Ah. There we go. So this is a good little teaching thing. I thought I was going to underline it, but it didn't underline it. Actually, I didn't even notice. So notice what happened. I forgot, or I mistyped this as orange and not oranges. And when I did that, the problem is that it says name error. Name orange is not defined. So if you click on that, it takes you to the line where the error is. And so you kind of have to look at it for a second, and then you say, wait, orange is defined. But then you say, wait a second, no, it's not. No, it's not. I used oranges, not orange. So there we go. So you have to fix that. All right, so now that that's fixed, let's try it again. Monday. Do you want to turn right or left? I want to turn left. And I want to take 13 oranges. And I hope this works this time. Yep, so now it says you have chosen a baker's dozen. Right? And so the point is that if you turn left, I guess, you're only allowed to pick oranges. Whereas if you turn right, so let's take, tell me a day of the week, ASDF, that's not a day of the week. Let's turn right. So now how many apples do we take, right? So now we're going to say, let's take 15 apples, right? So then it says, you have chosen a dozen or more apples. So, and you see how it doesn't let us pick any oranges because basically the way that these statements work is if you go into this first block, right? If you go into this first block, then only this code executes. Even if this code is another if statement, it still executes as part of this first if statement. So while this if statement is executing, you can put another if statement inside, right? And so here you can also do the same thing for left, and you can do something like this, okay? And so, yeah, so this is a good example of like the first example of like nesting. I think it's a decent example of nesting. So yeah, nesting is, so I'll call it nesting if statements, right? So if you put an if statement, inside of an if statement, that is called nesting. And you can actually do this multiple times. Now, generally, it's preferable to have if, elif, else than to nest. Okay? But you can always kind of nest if you need to. So it depends on what's the easiest thing to do. So they're not mutually exclusive. You can do both, right? You can have, you notice that I have it here, right? I have an if, an elif, and an else, and I also have things that are nested inside of the if and also the elif. So you can do both things, but sometimes one thing you should try to avoid is something like this. You should not say something like, if x is bigger than 1, then you can, print out, x is bigger than 1, and then you would do something like, if x is bigger than 2, you can print x is bigger than 2, and then you can do something like, if x is bigger than 3, print x, right? And that's a totally legal code. You can do this. There's nothing, and I'll stop here. And let's do x is equal to, right. So let's enter an integer and see what happens. So tell me a day of the week. Nope. Do you want to turn right or left? Neither. Okay, now let's give it an int. So let's give it the int of 7 and see what happens, right? So what's going to happen is, you see, 7 is bigger than 1, so it's going to print this, and then it's going to execute this next if statement. And it's going to say, is x bigger than 2? And then it prints x is bigger than 2. Executes next if statement. X is bigger than 3. Goes to the next if, etc., etc. So usually you don't want this, right? Because kind of this is sort of telling you multiple things. If x is bigger than 1, well, if x is bigger than 5, then x is also bigger than 4, also bigger than 3, also bigger than 2, also bigger than 1. So generally you don't want to see all 5 of these messages, right? So the way to kind of recode this with like ifs and elifs is actually to say something like this. You can start with if x is bigger than 5. And then what you can do is you can pull this one out and you can say elif x is bigger than 4. And then you can say elif x is bigger than 3. And then you can say Elif x is bigger than 2. I mean, I don't know exactly why you would want something like this, but whatever, you know. So all right, so let's do it again. So ASDF, okay, let's enter an integer, right? So the integer we're going to enter is 42, right? And so for the first one, we see that it gives us x is bigger than 1, bigger than 2, bigger than 3, bigger than 4, bigger than 5. And if that's what you want, if you wanted to print out all 5 of those things, then this is the way to go. This is better. But if you only wanted to print out one of those things, right? Since x is bigger than 5, we know it's already bigger than 4, 3, 2, and 1. So now let's try a number in the middle. So let's say, you know, let's give it 3, for instance, right? So it's bigger than 2 and bigger than 1. So here, we see that x is bigger than 1 and x is bigger than 2. But in the second time, it just says that x is bigger than 2, right? So, so that's kind of the way to handle. If you want to only print out one message, you kind of start from the most specific thing and you kind of go down to the most general. So you notice here that it's not exactly, it's kind of a trick in programming. You know, you might want to start with the most specific thing and then go to the more general. And so let me explain what I mean by that. Let's say that we flipped all of these around, right? So let's say what happens, you know, if we flip them. And so if we do something like this, where now we say, actually, I can flip the order much more easily. 5, 4, 3, 2, 1. And then, of course, 1, 2, 5. There we go. That's easier than copy pasting. We can print third run, or third time. Okay, so now I want to show you how this does not work. Okay? So, for instance here, if you wanted to do something, and let's say that we enter the int of 7 and see what happens. Right? So for the first time, it prints out x is bigger than 1, 2, 3, 4, and 5, as usual. Right? So this is what we expect. For the second time, it prints out x is bigger than 5. And that's nice. That's probably what we want. So that's good. But then, the third time, what does it print out? Does it print out that 7 is bigger than 5? Right? You know, it doesn't actually. And why doesn't it print out x is bigger than 5? It doesn't print it out because 7 is already bigger than 1. And so because 7 is bigger than 1, it gets stuck in this if statement. This is already true. And so because this is already true, it gets stuck in this if statement, and it never checks any of these other conditions. Right? So that's one thing to keep in mind. So note here that if you use, say, x equals 7, for instance, it will become true when x is bigger than 1. And it won't check x is bigger than 2, x is bigger than 3, etc. Because it's already found something that's true. So basically, that's, I think the moral of the story is it's important to think about what order you put your if statements in. And so you think like, oh, if x is bigger than 5, is it true that if x is bigger than 5, then x is bigger than 4? Yes. But is it possible that x is not bigger than 5? Right? And if that's the case, can it still be bigger than 4? So if x is equal to 5, right? If x is exactly equal to 5, then it's not bigger than 5, but it is bigger than 4. So this will become false, and this will become true. But if you look at that, for instance, here, where we plug in something like x equals 5, the point is that, is it possible that x can be bigger than 1, but then not bigger than 2? And the answer is no. So the point is that every time any of these are true, this one is going to be the one that executes, and all the rest of them are basically never going to happen. All of this code here is essentially what we would call unreachable, right? It's code that's never going to happen. Okay. So, yeah, so I want to discuss, I think at this point, I want to discuss, probably, I want to talk about mod. And it's not because mod has anything to do with if statements in particular, just because I think sometimes in the next homework you're going to find that we might use mod. So the point is that homework 2 may use mod. Or does it? Does it use mod? Yeah, it might. So let's talk about mod. So what is mod? So modulus division is the idea of remainder. So remember, back when you learned division, this is, then you used to say things like 5 divided by 3. You know, normally now you would say, oh, 5 divided by 3 is 1.6666 repeating, right? But if you go back even earlier to when you would say that 5 divided by 3 is actually equal to 1 remainder 2. And so that's exactly what we want to talk about when we talk about mod. When we talk about mod, what we mean is that we're actually talking about the remainder. So is mod. And so let me discuss how that works in Python. So if you have something that works like this, if you have something where you say divide, say, 17 by 5, right? That's going to be equal to 3 with a remainder of 2. And if you divide something, say, 20 divided by 4, this is going to be 5 with a remainder of 0. And if, let's do another one. Let's say we divide 6 by 7. The result is going to be 0 with a remainder of 6. And so in programming, what happens a lot of the time is that you're going to end up, in programming, you may see instances where you want to test, say if something is even or if something is divisible by 7 or something like that. And so I'll show you how to use mod to do that. And so how do we do that? So in programming, usually the symbol is equal to the percent sign. So this is the mod symbol. So let me show you some examples. All right, let's do some examples of mod. So first, let's get rid of all of this so we can talk a little bit about mod. All right, so let's print out 17 percent sign 5, 20 percent sign 4, and 6 mod 7, right? So let's print all these things out and see what they actually come up with. And here we'll see that, yes, mod is actually giving us the remainder, right? So you see that it's giving us 2, then 0, then 6. So that's how it works. Mod is giving us 2, then 0, then 6. And so the point is that let's do some other mods, right? So let's print out, say, 4 mod 2. That should be 0 because 4 is divisible. Let's print out 9 mod 5, right? Let's print out 8 mod 3. And let's print out 244 mod 7. I actually don't know what that one is, but we'll find out in just a second. So let's think about what these should be, right? Let's think before we calculate. So think before we hit the go button. So 4 divided by 2 is really equal to 2 remainder 0. So hopefully it's 0. And 9 divided by 5 is equal to 1 with a remainder of 4, right? Because really the way you want to think about it is 1 times 5 plus the remainder is equal to 9. And then also you want to do 8 divided by 3. So 8 divided by 3 is 2 with a remainder of, I think, 2. Yes. Because 2 times 3 plus 2, right, is equal to 8. And also, and so now what is 244 divided by 7? The answer is, I don't know. But if we're going to do it in our heads, then 244 is really equal to what? It's equal to 7 times something plus something. And so what is the first something? So the answer is that, what should it be equal to? I guess, is there an easy way to think about this? Is there an easy way? I don't know. Maybe I'll just let's use a calculator. Because I am not feeling like doing things in my head right now. So here's what I get when I do the calculation on the calculator. I get a 34.85 blah, blah, blah. So we know the answer is going to be 34 with a remainder of something. So what is 7 times 34? The answer is 238. So in that case, the remainder should be 6. So let's see if all of that is right. So this should be 34 with a remainder of 6. Okay? There we go. So now we see that the remainder is 6. So we see that it is 0, 4, which is correct. We see the next remainder is 2, and the next remainder is 6. Okay, so what's another thing? So what's the thing we can do with mod? So the first thing we often have to do with mod is to test if a number is even or odd. Okay, because if you have a number and you mod it by 2, if that number mod 2 is 0, that means that the number is divisible by 2, which is also known as the definition even, right? So that's good, right? So that means we have that, and if the number mod 2 is equal to 1, that means the remainder is 1. What that really means is that that number is equal to 2 times some number n plus 1. That's what it really means. And that is the definition of an odd number. So if we ever need to test to see if a number is even, right, or odd, this is the way to do it. You use mod. You mod by 2. So for instance, you can say x is equal to input of, tell me integer, and then we'll use an if statement. We'll say if x mod 2 is equal to 0, we'll print out x is even, and then we'll have an else statement, print x is odd. Okay? So that's that. So now let's run this code and test it. So let's say, tell me an integer. Let's say 14. 14 should be even. X is even. Let's do it again. Let's say 5. Nope, missed 5. X is odd. So as it turns out, there's a question about whether 0 is even or odd. And I usually ask it as a trick question, but here I'm just going to tell you the answer. As it turns out, 0 is even. And now you might say, is it the case that 0 is neither even nor odd? And the answer is no. Actually, 0 is an even number. And the reason why is because it can be divided by 2. And you divide 0 by 2, and you get 0. And that's an integer, right? Not a half. So yeah, that's actually, so it's true. The other way to say it is that 0 is equal to 2 times 0. So that's another proof that 2 is even. Right? Okay. So, cool. Let's talk about, so let's use mod for something a little bit more interesting. So let's talk about, say, days of the week. And the way to, not days of the week, days of the week, days of the month, right, is really what I want to talk about. So, for instance, this month started on a Thursday, so September 1st was equal to a Thursday, right? And then September 2nd was equal to a Friday, and then September 3rd was equal to a Saturday, and then September 4th was equal to a Sunday. And this is going to get boring fast, but whatever, Monday. September 6th was equal to a Tuesday. September 7th was equal to a Wednesday. And finally, September 8th is equal to a Thursday again. Now, what do we notice about... Okay, well, maybe we'll do a few more. So September 9th is equal to a Friday again, and then September 10th is equal to a Saturday, and then September, well, yeah, okay. So yeah, September 11th is equal to a Sunday, and then September 12th is equal to a Monday again. So let's say that I want to give you a day of the month, right? I want to say September 13th, September 21st, September, whatever. So I want to give you a day of the month, and I want you to tell me what weekday it is. And so the thing that you want to notice here is that September 1st, September 8th, and then what is it going to be? September 15th is also going to be a Thursday. September 22nd is a Thursday, and September 29th is a Thursday. So the cool thing about that is that 1 mod 7, 8 mod 7, 15 mod 7, and 22 mod 7? Yeah, it has to be 22 mod 7. Are all equal to, right, let's give it 4. 4 is even. The good news is those are all equal to 1. So all of the Thursdays of the month are equal to 1 mod 7. Nice. So then you can say something like all of the Fridays of the month are going to be 2 mod 7. And all of the Saturdays, right, all of the Saturdays of the month are going to be 3 mod 7, etc. Okay? So the idea here is that you can basically tell me what day of the month it is just from knowing the number and just knowing when it starts. So let's actually write all that out. So let's say if day of the month, right? Let's input day of the month is equal to int input enter what day of September it is, right? So we're going to enter what day of September it is, and then we're going to say if the day of the month mod 7 is equal to 1, then we're going to print it is Thursday. And then I'm going to copy paste so then we're going to say Elif, the day of the month is equal to 2 mod 7. Then we're going to say it's Friday. And then we're going to do a lot of more of these. So if it's 3 mod 7, it's going to be a Saturday, right? If it's 4 mod 7, it's going to be a Sunday. If it's 5 mod 7, it's going to be a, well, okay, I'll write them in. Saturday, Sunday, Monday, and finally, what have I done? Thursday, Friday, Saturday, Sunday, Monday, Tuesday. I skipped one. 1, 2, 3, 4, 5. Yes, 6. Good. So now, one question, or 2 questions. What happened? What happened to Wednesday? Right? So, if we look at this, we say, okay, the numbers can be either 1, 2, 3, 4, 5, or 6 mod 7, but what else can it be other than 1, 2, 3, 4, 5, 6? So as it turns out, it cannot actually be 7 mod 7, and I'll show you why not. Because if you print out, let's say we just print out 7 mod 7, what it's going to give us, and let's just test out the code a little bit. So let me say, tell me an integer, I don't know, 45. Okay, so what day of September is it? So let's say it's September 7th, right? And so, or let's say September 5th, and let's try to get it to say that it's a Monday, right? So it's a Monday, and is that right? September 5th was actually a Monday, so that's correct. Let's try out September 12th. I think that should also be a Monday because we add 7 to it, and then maybe September 19th. So let's say September 19th. Is that a Monday? It is. But now let's try to say, let's do September 7th, and that should be a Wednesday, right? But it doesn't do anything. So the question is, why does it not do anything? Right? What's the problem here? And the answer is kind of this 0, right? Yeah, so if you look up here, 7 mod 7 is not actually 7, right? 7 mod 7 is 0, right? So be careful about that. 7 mod 7 is equal to 0 because it has no remainder, right? So 7 mod 7 is not equal to 7, it's equal to 0. You could also do an else, but you could also do something like if this mod 7 is equal to 0. So that's the right thing. So 7 won't work, but 0 will work. So let's try that. Let's try if you enter an integer of 4. Let's just try September 14th. That's today. So it should be a Wednesday. Turns out it is a Wednesday, right? So, yes. So there's two things to learn from this. Let's write down the things that we have to learn. Remember that a number, mod itself, is equal to 0. So be careful a little bit of that. This is not exactly rocket science or shocking. It's just that if you're taking a number and you're asking what the remainder is when you divide it by itself, it's 0, not the number. It gets confusing when you're coding and so if you were just writing this as code and you were doing the copy paste and you just stick a 7 in there and you don't think about it too hard, that's when you're going to run into problems, right? So that's why I'm talking about it. The other thing to say is that what is the other? I forget the other things. Oh yeah, 0 is a possible answer for mod. So always remember that 0 can happen, right? So technically, if you were writing this code in kind of a better way, maybe you'd even start from 0. Maybe you'd do something like this. You would say, if the day of the month is equal to 0, elif the day of the month is equal to 1, 2, 3, 4, 5, 6. And there's nothing different about this piece of code versus the other piece of code. Like, they're both going to function the same way. The only difference here is that here you're going 0, 1, 2, 3, 4, 5, 6, and everything's kind of in order. And most of the time that's better. You could jumble all these up, but then if you ever had to recode something in here, it might be confusing. So that's why you want to avoid that. Okay. What else do I want to talk about with regard to if statements, else so here's one thing about mod in Python. Mod in Python. So beware. You might say to yourself, okay, what is -3 mod 7? Right? What is -3 mod 7? And the answer is, well, let's find out. The integer is 5. The day of September is 12. And so it says it's 4, okay? So -3 mod 7 is 4. And so you might think to yourself, well, why isn't it just 3 or -3 or something like that, right? Why is this not just -3? Because as it turns out, if you did the division, -3 divided by 7 is equal to 7, right? The divisor times 0 minus 3, right? The remainder should just be a -3. Why not? The answer to this question is that remainders are positive, or at least non-negative in Python. So it does a little bit of a fix for you. And so what I mean by that is that -3 divided by 7, as it turns out, is not equal to 7 times 0 minus 3. It's equal to 7 times -1 plus 4. And you think to yourself, is that right? So -7 plus 4 is truly equal to -3, so yes, that's right. And so the only difference here, and the choice that you have to make, is that whether or not the remainder can be negative. And so because the remainders cannot be negative in Python, that's why you end up with -3 mod 7 is equal to 4, and not equal to, say, -3, or something like that. So that's just something to keep in mind with Python. I will say that next semester in C++ does not do that. So I think I can even prove it. It's probably a dangerous thing to try to prove it, but let's see, code blocks. Do I have that installed? No. It's true, I promise. And actually, that surprised me when I started to learn Python, because I learned C++ first, and it surprised me that Python actually corrects this. This is actually more like mathematicians' version of mod, where the mod actually gets corrected to something positive because remainder should be positive, but C++ doesn't do it. So anyway, okay, let's just do one more example maybe of, let's do like a little choose your own adventure or something. Or, you know, what character is this? And so I usually do something like, I'll probably do another one in class on Monday, and I will come in on Monday. So for everybody watching this lecture now and also in the future, if you watch this YouTube video later, we will have class in person on Monday. The car issue is just a battery, so unfortunately it died right before I was going to come into teach, so bad things happen. So anyway, let's do, normally I would do Star Trek, because I love Trek, but I'll do Star Wars this time. And the reason why I'm going to do Star Wars, we're going to do the original Star Wars. So what I'm going to do is basically, we're going to ask a series of yes or no questions, and I kind of like these. They're good little tests for whether or not you understand how if statements work, and how nesting works, and how all this stuff works. So if you can make yourself a little choose your own adventure, or a little what character is this thing, then you should be good. So for instance, we're going to, like, the first question we're going to ask, we'll input, the first question I'm going to ask is, are you a gigantic furball? And we'll say furball equals input that. If furball is equal to yes, then we're going to print you are a Wookiee, right? And then we'll also say, input, are you Chewbacca, right? And Chewbacca equals input. Am I Chewbacca? And so we'll say if am I Chewbacca, we'll print out Chewbacca. You deserve medal. I don't know if you've seen the original Star Wars, he doesn't get a medal. And then else you say, you are another Wookiee. You also probably deserve a medal. But let's say you're not a furball, so else. Let's say you say no, right? So Elif, furball equals no. Ah, yes, you're right. Ha, thanks. That's right. Yeah, I mean, I think it was just because he didn't wear a uniform, right? Because he's kind of, he's made of fur, but otherwise, I guess he's naked. It's hard to determine with Chewbacca what's going on there. So, all right. So you're not a furball. So now I guess we'll ask the question: are you a Jedi? Right. So there's a few Jedi now. Jedi. And so if Jedi is equal to yes, right? Then maybe we'll ask, did Darth Vader cut off your hand? Right? Vader hand. And if Vader cut off the hand, right? Then you're Luke, probably, right? I think Vader only cut off Luke's hand, so he will say, you are Luke Skywalker. And then, what are some other Jedi? Oh, yeah. Oh, what? Good point. Well, no, but, Anakin and Darth Vader. So, yeah, I guess we'd have to ask another one. We'd have to ask, What would we have to ask to figure that out? Well, let's just simplify. You're right, the Count Dooku also may be in here. Right, so we'll fix the code later. Technically different characters, I like that. So, okay. What are some other Jedi? So, I guess another Jedi could be, so... I know what. Hello there. Right? Do you say hello there a lot? Right? If hello there equals yes, then you are Obi-Wan. Right? So, let's play this little game. Right? Let's tab everything else in so we don't have any of the other code. I might get rid of all that tabbing right before I upload it to the GitHub. But let's just play this to see how it works. Right now we don't have a lot of characters in here yet, but you can add as many as you want. And you can think, let's say I am not a gigantic furball, and I am a Jedi. Did Darth Vader cut off my hand? No. Do you say hello there a lot? Yes. Therefore I'm Obi-Wan. Right. So you see how it works, right? So you can kind of you can use nesting, and you can use chaining of things in order to get into various statements. So let's say else, right? So let's say you're not a Jedi. We'll ask, that's how you spell smuggler, yes. Input, are you a smuggler? A heart of gold, right? If smuggler equals yes. I guess technically also Lando Calrissian was a smuggler, but I guess he's a governor of Cloud City or something, so, you know, whatever. Oh, yes! That's a good one. That's a good one. Because both of them are... Yeah, that's a good one. Yeah. Did you shoot first? Equals input. If yes, then we can print out print. You are Han Solo. Else print. You are Lando Calrissian. Right? Good. Yeah, I mean, we could ask about Cloud City too, but as it turns out, you know, as long as you're a smuggler who didn't shoot first, then we'll call you Lando. So you kind of see how this works, right? So we can make this super big. I usually do we have to study stars before continuing with the class? The answer is no, but you know, I like it as an example. I think I always alternate between Harry Potter, Star Trek, and Star Wars, and whatever else I could think of. I think some students have suggested some other things in the past, but the moral of the story is that I think that, you know, I've done Harry Potter. I like Harry Potter. You know, Star Wars is good, Star Trek is good, but the only problem with Star Trek is that no one knows anything about Star Trek anymore. Oh yeah, Lord of the Rings, I've done that one before. Exactly. Right? Because you can do, like, are you a wizard, right? If you're a wizard, then it's, are you good or evil? And that determines if you're Sauron or Gandalf. Or, I guess Saruman, really, or Gandalf. And then, you know. It's like, do you really like rings? Kind of thing. Yeah, no, I know. It's just, it's a sad fact that a lot of people don't love Star Trek. But anyway, that's exactly right. A Jedi who beat Kobayashi Maru. So, here's what I want you to do. So I want you to, like, look at this code and play with it, and I want you to do, you know, if you want to make a Lord of the Rings one, if you want to make a Hobbit one, if you want to make a, you know, Star Trek one, you know, just play around with that. And if you can do that like this, you can basically, you understand the flow for nesting if statements, you understand the flow for if and elif, right? So that's it's basically a little bit of a practice problem that you can do. And also, it's not an official assignment. It's not official, but what it is it's probably going to be on the homework. So it's always good to get a little practice. Alright, so with that, I am very sorry that I did not make the lecture today. This should be the only time in the semester where I do this. Hopefully, once I get a new battery, my car will run and not just die immediately as soon as I try to turn it on. Who knows? So, I hear you about the homework, but here's your opportunity. If you really love the homework so much, then you should go and do these problems before you get the homework, and then when you get the homework, you'll, that's the problem, is that it would be nearly impossible to grade. Almost impossible to grade, because if students were allowed to be too creative, then some students would write amazing code, but then some students would write code that doesn't work, and we'd have to determine what to do with it, or if it's intentionally not the code that we asked for, kind of thing, and that's always hard. So anyway, thanks everybody for being patient, thanks for watching the lecture. Hopefully most of you will watch the lecture at some point. I'll probably do a little bit of a review about this on Monday, just because I know some people won't watch all of this. Anyway, I'm gonna sign off. So get ready. Outro.